What is up, Joe Gamers? Today we'll be doing quick load Joe gaming on some vectors again. I know, kinda crazy, but yeah. So today we'll be learning about how to make a line in the 3D space. Yeah, and also a plane if I have time for that.
After visiting Plaza de la Familia at Disney
Okay,
California
so
Adventure Park, you'll remember the music, the
a
food,
line,
and most of all, the
like,
time spent together
say
as
this
a
is in
family.
2D.
August 22nd through November 2nd. Visit Disneyland.com for details.
This is
At Ralph's,
X,
you never
and this is
compromise.
Y.
You get high quality and low prices. Like you never compromise your meal
You'd
with our
say
spring
this
salad
line,
mix that's guaranteed
I mean,
fresh.
there's
And you
multiple
never
ways to write
compromise your budget
a
with lower
line,
than
like
low prices. Hand it to Ralph's
AX
shoppers.
plus
You never
Y,
compromise.
whatever that
Ralph's.
form, but we're not doing that form.
Fresh for
Usually
everyone.
it's in
And now,
Y
shop what you
equals
love and
MX
save $2 on each participating item when you buy 3 or more
plus
with your card.
B.
Ralph's, fresh for everyone.
And technically, yeah, this is a form, a simple form to get any line, any straight linear line in 2D. And you could use that form in 3D, but it's in a slightly different format. So here in this, let's call that Y instead. And call this X, and this is the Z plane. And let's get a different color in here. So let's say our line. Oh, why does it go under? It's so weird. Yeah, that's weird. You're telling me. Alright. What brush is this? Hold on. Pencil. That sucks balls. Right here. So we have a line. Oh crap. So this is our line, right? Call it L. It's our line. And the way we would define this line. Hold on. I forgot the notation. Give me a sec. Okay, yeah, so the notation for any vector function is usually R of t. And R of t is a vector, but we're defining the line as kind of this vector. And this is the vector form of a line in 3D. Yeah, 3D. So R of t equals RO, which is the initial position of a vector, plus a vector parallel to the line times a parameter t. I'll get into what all this means first, but R of 0. So anyways, so suppose you had a, let's see, change this color real quick. So suppose you had a vector R like this, and another vector, say, over here. And we call this vector R. And we call this vector RO. So, and then let's get another color here. And then let's say you had another vector that's parallel to the red called V. Now, this right here would be from this perspective of R, it would be RO equals, well actually no, my bad. This little section right here would be RO minus R, and then its direction, or at least let's say this, yeah, let's say not this thing is parallel to the line, this whole line, and also equal in magnitude to this green section. Yeah, it's equal to V, right? That's what we're defining V, because it's pointing the same direction and it's has the same length. So RO minus R equals V, right? Hold on. It might be the other way around. Come on. Whatever. It don't matter. Maybe I should have just pointed it RO up here. That would have made more sense. Anyways, so say RO started here and R started there. That means the whole length is V. Now the reason why there's a parameter T is because let me get up my notes, hold on. I'm digging in my butt crack. Alright. I reviewed my notes. Pardon me for the mistake. V is simply just a vector parallel to L. It is not the length of this. This length we're gonna call we actually call it A. This length is A. So we write that this is A. And it's actually, more specifically, it's R minus RO equals A. Yeah. And therefore R equals RO plus A. In the previous video I showed you the vector addition stuff. You can see that this vector goes here, this vector goes here, so adding it from here to here would bring you to R. That's why this is true. Now this is where VT comes in. V is in the same direction as the line, and T is just any point on this line. So that should mean that for any A, so it's just generalizing A for any value. That's what it's essentially doing. Let me see my notes real quick. Yeah, so basically we're gonna, R will be held constant, and R vector basically moves along the line as we change as we change T, with V conserving the information of the line. So you're always somewhere on the line. Like, without RO, you would have the I think you'd probably have the wrong position. No shot, but like, I think you're trying to hopefully see what I'm trying to say, that instead of A, we move R from RO with any T, and we basically y equals mx plus b. V is the slope and T is x. This A is just to represent that vector. So no matter how far R goes to the right or left, like let's say this was R again, then this is our new A, because it's pointing to that way. So that's what this equation is saying. Let me see how much time I got left. Yeah. So that's all you need. You just need a vector
This is an ad by BetterHelp. We've all
and
had that epic rideshare experience.
a starting position RO. You need a parallel vector to the line and RO to make a line in 3D. But there's also another way, and this way is called the parametric equation, and I think it goes like, let's see.
Time to restock your pantry? Ralph's offers
All right,
the same great prices and quality online that you get in store.
Oh yeah,
From pasta
okay.
to cook for family dinners to school lunch
So,
essentials. Get what you need when you shop, pick up,
since
or delivery.
R
If you're not 100% satisfied
T is a
with your online
vector
order, we make it right.
and
Guaranteed.
RO is a
Ralph's,
vector, you
fresh
can
for
define
And now, shop what you love and
a
save
lot of
$2 on
things
each
as a
participating item when you buy
vector.
3 or more with your card.
So let's say
Fresh for everyone.
RO is defined as ABC,
Okay, kids. Ever seen a BMO debit card disappear? It goes
and then we
under my
plus
hat, and with a twirl of my
crap.
wand, magic, it's gone.
another
Cool. Can you bring
vector
it back?
V.
No,
We call
but I
that
can lock it on my
D,
phone.
and then we
Okay,
put T,
so what
distribute the T,
Now I go to a BMO branch
ET,
and get a new one printed instantly.
sounds like BMO are the real magicians.
FT.
Like that.
Accounts are subject to approval and are provided in the United States by BMO Bank N.A. Member FDIC.
You see my notes? Oh yeah, and then it's equal to R of T, which corresponds to X, Y, and Z. And in order for this vector or this whole equation to be true, you must observe that X equals A plus dt, Y equals B plus ET, and Z equals C plus FT. Now this is what's called the parametric equation, but there's also another equation. What is it called? There's a thing called the symmetric equation. If you don't want the parameter t and just want x, y, and z, you can solve for t obviously, and we can get the equations x minus a over the slope, so we call it b, and that's also equal because they're the same t, right? Y minus b over e, and it's also equal z minus c over t. I mean, what the hell? F. See how they're all their own like little equation. And by the way, this whole thing defines a one line, not one individual piece of it defines the line. Alright? But this would tell you the direction in A. And all you need is to prove the line, or if a line is something, I think you just need two of the variables to show it, but whatever. So this equation is a symmetric equation, and typically it's not, you're not gonna really use it. This isn't what you're really gonna use mostly, because these parametric equations are more easier to use and more versatile. So yeah, remember, a line L just needs another parallel vector V and another vector R and another vector not at R, RO, to create a line on the line, line segment on the line that's called A, such that r plus a equals r, or ro plus a equals r. Let me see if I can add a little bit more information. Should I say anything more about this, like line segments? Nah. Wait, actually, maybe. Wait, how much time I got? Like 15 minutes? Yeah. So let's real quickly. Let's say, remember the thing I said about you can move any vector anywhere, right? Now, I might have lied earlier, said that v wasn't the length of a. It actually was. My bad. So v is actually the length of a, but t just multiplies that length to get you the right position, but whatever. Anyways, so that I've replaced v and a, we can prove that ro plus b equals r, right? So that would mean that r of t, that's so hard to write in, equals ro plus t times. Now, if we're gonna solve for v, we get r minus ro, so we can do r minus ro. And if you simplify the equation, you'll get that it is equal to ro times 1 minus t plus tr1, where, well, like I said earlier, okay, so this is a line for a line segment, so this has to be r1 because we're having a line segment, so it can only be a set r and r1, ro and r1. And the reason why this works, but only between 0 and 1, this equation only works between t equals 0 and 1, because, well, if you plug in 1 here, you just get r1, which is the end of the line segment, and 0, put in 0, you just get ro. Now, what this basically means is if ro and r1 were at the infinite ends, let's say ro was negative infinity and r1 was near positive infinity for a line, this still works because we can like think of t as like a percentage bar, and as starting from 0, you're at 0%, you're at the very end of the line segment, and at 100% you're at infinity, the end of the line segment. So no matter what size your line segment is, this t symbolizes the percentage of the line segment you're at. Alright, that's it for line segments.